Hi everyone, and welcome to this Valkyrie sound tutorial, the next in a series on reproducing the breathing system in The Last of Us 2. In this video we're going to use Quartz to generate a regular pulse, and this is going to be the heartbeat for our player. We'll combine this with a switch on the player state, which we looked at in the last video. Later on we'll use the same setup to create a heartbeat for an AI character. Quartz is available in Unreal Engine 4.26 and onwards, so you'll need that version to follow along. Quartz lets us generate a regular pulse. It's modelled on musical concepts around time, so we have beats per minute, we have bars, just like in sheet music, and we have the ability to play sounds in precise locations within a bar. In this example, when I press a key, I trigger some horns, but they'll only play on the first beat of a bar, no matter when the key is pressed. This keeps that horn section in time with the rest of the music. Using Quartz to manage a heartbeat is going to be better than using a float variable, because we can make sure our sounds line up with each other and we can easily adjust the speed at which they play. So we're going to build Quartz in the third person character BP, and this is what it will look like. I'll give you a quick overview of things and then we'll go into the detail. So in this section here we are making our clock and we are establishing our time signature. It's important to know that all clocks are paused by default when you make them, and we'll activate the clock in a moment further down the line. Next, we're going to trigger a sound to play in this section, and then we are going to subscribe to each beat of the bar. When our first sound plays, we are going to send a signal to an event over here, and this will unpause or resume the Quartz clock. This second event dispatcher here sends out a signal on each beat, as defined in the subscription node, and that will send an execution pulse through here on each beat, and when the Boolean check criterion is met, we're going to play whatever the player state is telling us to play. If the character is running, we'll get our running breaths. If they are standing idle, we'll get our ambient breaths. First of all, we're going to create a custom event. I've called mine Start Breathing System Audio Manager, but you can name yours something more convenient and easy to say. This has been called from the Event Begin Play node. Next, we want to right-click and type in Quartz, and we want Get Quartz Subsystem. From that, we want to create a new clock, and I'll get you this node here. Hook that up to your custom event. And we now need a name for our clock. We can't leave it as none or it won't function. So either type into the box that's there, or you can promote this to a variable like I've done. From the in settings, we want to drag off and get the Make Quartz Clock Settings node. We're not so much interested in that, but we are interested in the node that comes before it, the time signature one. So drag off from there and add this one. Most music is in what's called 4/4 time. There are 4 beats in the bar. 1, 2, 3, 4, 1, 2, 3, 4. The top number tells Quartz how many beats we want in every bar, and the bottom number in this drop down tells Quartz what each beat is worth in terms of a note value. So here we have our half note, quarter note, eighth note, 16th and 32nd notes. Right-click on the return value and promote to variable. We'll be referencing this throughout the section, and you can name it whatever you like. From there, we'll add a set beats per minute node, which is this one. Although we do have other options as well, scroll down to those, we can select different time values, but for this, we'll just leave it as beats per minute. Again, it's a common musical convention, and it's easy for us to use. I've got a disconnected float variable here called player state BPM. I'll talk about that later on. For now, we are setting the BPM, the beats per minute, to 100. From the set beats per minute node, we'll add a play quantize node. And into this, we're going to add an audio component. So in your component section, go to add component and audio. And we'll need a component for each player state you're using. All of these, as you can see on the right hand side here in the details panel, all of these have different sound cues attached to them. In the last video, we defined ambient low as being the default breathing state, so I've connected that one to the target. Clock handle, we get that cached reference that we had before, we dragged it in from our variables, and we add that into clock handle here. In quantization boundary, from that we want a make Quartz quantization boundary. And I've set this to bar, 1, and transport relative. This node tells Quartz when to play this attached sound. So we're telling Quartz that the division of time it should look at is bar. So our sound is going to play on a bar. Then we're telling it which bar to play on, in this case the first bar. And the third option gives Quartz the context for the first two options. So bar relative tells Quartz to look within a bar. So we need to define a quantization smaller than a bar, such as a quarter note or a half note. Transport relative tells Quartz to start its count when the clock resumes. So here we're telling Quartz to start at the beginning of the very first bar, right at the start. And the current time relative sets now as the starting point from which Quartz will count. So if our clock was already ticking away and we'd set the sound to play on beat 2, but we were already on beat 3, the sound would play 3 beats later. It would play on beat 2 of the next bar. The keyword here is relative. Where in which bar, where in the overall transport, and where in time. From the indelegate input, if we drag out and we want to create event dispatcher, so event dispatchers and then create event, and we'll come back to that in a moment. Next we'll drag in another reference to our clock handle, and from it we'll get the subscribe to quantization event node. Again, there are different things that you can do here. We can subscribe to all quantization events or just to a specific one. Now, for this setup, we're only interested in the beat, so we don't want to subscribe to all quantization events, we just want to be able to subscribe to the beat. And again, from that red spot on the quantization event input, we'll get a custom event dispatcher. So this dispatcher is going to trigger on the quantization event that we've defined in the dropdown on every single beat. If we change that to bar, then we trigger that dispatcher on every bar. So from that first event dispatcher that we made, click the drop down and select create a matching event. That will get you a node that looks like this, although it will spin you halfway across the blueprint, so just make sure you bring this to wherever you want it. From the event type pin, if we drag out and we want to get a switch, this switch on eQuartz command delegate subtype. Next, we'll drag in a reference to our clock handle again, and from that, we'll get the resume clock node. When this sound is triggered, that event dispatcher will fire, send a signal through here, and it will resume the clock. And from the second event dispatcher, we're going to do the same thing. Click that drop down and create a matching event. It'll ping you all the way across the blueprint, bring it back to where you want it, and you'll have this. From the execution output, we'll add a sequence node because we'll run through this debug. So from the second output of the sequence node, we add the print text node, and into that we want the format text node. Curly brackets give us inputs so we can hook up the number of bars, the beat, the sound we are going to play, we'll come to in a moment, and BPM will be our current heart rate converted to a BPM that we can use to modify the speed at which our breathing sounds play. As the player's heart rate increases, our BPM will increase, so the player's breathing will get faster. So for that we are taking the current heart rate value and we are adding 100 to that value. We're taking another reference to the heartbeat and we are multiplying that by 100, and then we are adding those two values together. So the value of our heart rate ranges from 0 to 1, sometimes it will go a little bit over 1, and this calculation sets our 0 baseline to 100 BPM. So we could use a map to map the float instead, but this way we don't have to define an upper limit. If we needed our heart rate to go up to 300, then it could. From the quantization type pin of the custom event that we have here, we want another switch. We want the switch on eQuartz command quantization. And this gives us a whole option of beats, bars, and all the different note values that we can have. And because we're focusing on beat, from the beat output, we are going to add a branch. And then we'll add a greater than integer node. So integer greater than integer. And the lower value for this will be 3. And the upper value will be connected to the beat output of this node. Now I'm typing in 3 here because I've been having some issues with the system playing cues correctly on the first and second beats of the bar. I think that's because of the way the sounds are being selected in the player states section, which we'll come to in a moment, but the sounds cue correctly on the third and fourth beats of the bar. With the system set up as it is at the moment, it's irrelevant whether the sound plays on beat 1, beat 2, beat 3 or beat 4. All we are interested in is an equal gap between the sounds. So long as it plays on the third beat of every single bar, that's fine. We have our regular pulse. That said, I will try to figure out why this is happening and correct it in a future tutorial. From the true output, we want our play quantized node, and into that we'll add a new variable called sound to play. So a new variable here, which is just an audio component. We're going to update this value depending on the player state. Then we are going to add the clock handle in again, and that make Quartz quantization boundary, and this is bar, 1, and transport relative. So this section here will be triggered every single beat, and when the beats are greater than 3, when we have 4 beats, on the 4th beat, that value will be true, and we will play the quantized sound. And that sound is being played on a bar by bar basis. So this will be played on the next bar.
K. Ka. E.
So here we have
K.
1, 2, 3, 4.
A.
1, 2, 3, 4.
Sa. Su.
2, 3, 4.
E.
2, 3, 4.
Ka.
So this is just a placeholder sound at the moment.
K.
But you can see this whole thing ran at the very beginning of the game, and now this is just running based on that clock that we had running earlier on that we unpaused.
Ka. Su.
So this is our beat pulse coming through,
E.
and when it reaches more than 3 beats, when it hits the 4th beat, it's going to say, yep, that's true, play the sound, and this tells it when to play the sound. So it's going to play the sound on the first bar that's coming immediately after that beat. Next we'll set up the state switch, which is this section here, and for this we're going to need a new custom event. I've called mine select next breathing sound, and this will be triggered from the event tick. From that we'll add another set beats per minute node, so we need our clock handle connected into that as well, and that's because the first set beats per minute node that we added was being fired as part of the event begin play sequence. It'll only happen once. We want to be able to modify our BPM dynamically depending on the player state. If they're idle, breathing will be relatively slow, BPM and heart rate will be low. If they're running, breathing will be fast, BPM and heart rate will be high. So here we have that same calculation that we talked about earlier, and we are plugging that into the beats per minute. And here we have another reference which has been plugged into a player state BPM, the same one that we had detached from the first beats per minute node up here. So this is an alternative way of managing the BPM based on the player state, and it's less reactive. So this calculation will modify the BPM based on the current heart rate, which is always changing. The value that's currently being monitored, and every tick we have a new value being updated. This is a fixed map, so when we switch to a different heart rate, it'll set the corresponding tempo and it'll just flick to it. We won't have a gradual increase or decrease to or from that new tempo. It will just move to it straight away. So that's just another way to update the BPM. It's not as responsive, but it might be useful in certain setups. So this is a map with a enum linked to the player state, which again was covered in the previous tutorial, and that's linked to a float value. Later on, we can access this value to trigger certain events in other BPs, or we can override and clamp it if we needed to set a specific heart rate, such as for a cutscene. Over here, we are taking a reference to our player's current state, and that will update depending on the other variables that we looked at last time. So that is this section down here, which selects the state depending on what the player is doing, what they're experiencing, what their environment is. So the very baseline, we have our ambient low and high, depending on the current heart rate value. We have our stealth section, combat, and so on. Vertigo, claustrophobia, those sorts of things. So as the player interacts with their world and moves around and spots danger or feels like they're in danger, their state will change. And for each state, we want a different type of breathing. But the most important thing, using Quartz, is that we can adjust the speed. And this is the laborious part. For each of our player states, we need to link it to a set sound to play. So that sound to play that we linked into our play quantize node earlier on, we are setting that for each state. And the audio components I mentioned earlier, each of those is dragged into the corresponding set sound to play node, linked to whatever player state it should be in the switch. For default, I've just run this into the ambient low, and I've got a couple of comment boxes down here. For the animation and the one-shot states, we'll require additional functionality for those, probably within the sound queue or in a function within this blueprint, because we need to know what sounds to play with what animations, and we'll have a list of one-shot sounds that we would need to select based on whatever the situation is. Next, we'll have a look at our sound queue. So we'll compile and save that. And let's have a look at the ambient low sound queue. So here we have placeholder sounds attached to a random node. Now, drop back in to our world, run around. If we look at the top left for the player, we're going to see our BPM, heart rate BPM changing. It's peaked.
E. K. So.
And you can hear a difference in the pace, in the speed at which the sounds are playing. And there was a difference in the audio there, so let's have a look at that. If we get our sprint, we have the same setup. I think it's exactly the same nodes, but we have a modulator in here as well, and I've just pitch shifted these sounds up to 1.6, so it's noticeable that the sound is different. That's just because I'm using placeholder sounds. So let's try this out with running around and getting vertigo. Something I'm sure you've all wanted to experience. So here we are on ambient high, now ambient low. So in this setup, as we run around, we go from ambient low to sprint low. And we'll get to sprint high. Notice that our heart rate is increasing. Ambient high, as the heart rate is coming down, we're no longer sprinting. Below a certain value, we'll have heart rate. We'll have ambient low. Below 150, I think it is.
A. So. E. A.
And the heart rate gradually returns to the base, to 0.
K.
And if you look at the mapped BPM below, that would be the value that the heart rate would just automatically flick to if we were using that map, if we weren't taking it from the heart rate. So I think for this setup, we'd probably miss something of the dynamism of this if we just use the mapped version. So now, as we get higher, we have a low vertigo. So heart rate is a little bit faster. We would trigger in different types of sound for this. As we get higher, heart rate's going up. Get towards the edge, heart rate going up even more, so our breathing rate is faster. We could trigger visual cues at this time, so we could maybe make the camera sort of wobble a little bit, depending on where the camera is looking. As we move away from the edge, heart rate goes down. Go up again. Got our wind set up with the spline that I talked about in a previous video. So the spline will follow the player around, and it just creates some air around the player to show that we are high up. Really high vertical heart rate now. If we jump back over here, heart rate coming down, and we're back to a more regular heart rate pulse. Oh, and our AI is searching. It's now in frenzy mode because it's found the player. Running away from it, it should disengage. There we are. We have a one-shot sound, and now the AI is back to its ambient low. And that's it. Take care, good luck with your own projects, and as always, thanks for watching.